Hi, welcome back to Moose and Chemistry. This lesson's on empirical formulas. So what we're going to do is, given an unknown sample, and we know the elements it's made out of, we can calculate the actual chemical formula for this compound by figuring out what is its percent of grams for each element. Okay, let's look at the first problem here. We're going to work two problems in this lesson. A compound that is unknown has a mass that is 3 grams. Looking closer, it was found that it contained 1.2 grams of carbon and 1.8 grams of oxygen. What is the empirical formula? Okay, so when we look at this, we have to think about, okay, we got this in grams. So we know that the law of definite composition talks about elements are combined chemically in simple whole number ratios. Those simple whole number ratios are not grams, they're moles. Okay, so let's take this and let's set this up. So go 1.2 grams times 1 mole of carbon. Well, if we look on the periodic table, we'll see that 1 mole of carbon has a mass of approximately 12.01 grams of carbon. Okay, so when we do that, we cancel out our grams. So we take the calculator and we're going to divide the two. And we find that this contains 0.0999 moles of carbon. Okay, so we've determined that. Now we need to look at how many grams of oxygen, if we had 1.8 grams of oxygen, how many moles are we going to have? So we're going to go 1.8 grams of oxygen. And this is going to be monatomic oxygen times 1 mole of oxygen divided by 16.00 grams of oxygen. Okay, so cancel that out. And we know this because, why it's monatomic? Because it's involved in a compound. So it's not like free oxygen, which would be normally diatomic. So we divide that by 16.00. We get that to be 0.1125 moles of oxygen. Now, to figure out the empirical formula, what you need to do is you need to take the smaller of the two and divide each element by that smaller of the two. So let's look. This is 0.999, and this is 0.1125, which is a smaller number. Why? This one is, of course. Okay. So now what we're going to do is we'll set this up into a ratio. So we're going to go 0.0999 divided by itself, 0.0999. And that's for the carbon. And for the oxygen, we're going to divide this again. We're going to go 0.1125 divided by 0.0999. So when we divide this number by this number, we get the number 1. And when we divide this number by this number, let's see what we get. So divide that by 0.0999. That's going to give me 1.1. Okay, that's close enough to being 1. So this problem is going to tell us that we have 1 carbon and 1 oxygen. So when we write the empirical formula, it's just going to be CO, which is carbon monoxide. Okay, so let's erase this problem and let's do another one. Okay, here's our second problem. A sample of gas which contains carbon and hydrogen has been compressed and liquefied. It was found that the mass was 4 grams, which contained 3.6 grams of carbon and 0.4 grams of hydrogen. What is the empirical formula? And better yet, what is the name of this chemical compound? We can actually determine that too. All right, so let's go ahead and do this. So we have 3.6 grams of carbon, so that's what we know. Okay, so we go 3.6 grams of carbon. We want to turn this into moles of carbon just like we did in the last one. So there are 12.01 grams per 1 mole of carbon. So when we do the math here, we take 3.6 divided by 12.01, which is going to give me 0.2997 moles of carbon. Okay, so let's look at the other one. We have 0.4 grams of hydrogen. Now this is not going to be diatomic hydrogen because it's in a chemical compound. So this is going to give me 1 mole of hydrogen divided by, again, 1.01 grams of hydrogen. And that's what we find, again, on the periodic table. So let's go ahead and do the math there. And that gives me 0.3960 moles of hydrogen. Okay, so now we have to do the molar ratio, because remember the law of definite composition says that chemicals are combined, elements are combined to make chemicals in simple whole number ratios, right? So we go 0.299 divided by the smallest one, which is that same number. This is going to be for our carbon, and our hydrogen is going to be, of course, 0.3960 divided by 0.2997. When we do the carbon, we get 1. When we do the hydrogen, we get, for one moment, I plug this in the old calculator. It's going to be approximately 1.3, but let's just make sure. And it's actually 1.32. All right, so now we're going to have to at least triple this, because at one point we want to get as close as possible to being a whole number. So if we triple, we have to times this by 3. And we'll have to times this by 3. So this is going to give me 3 here, and this is going to give me, let's see, times that by 3. That gives me 3.96. Well, 3.96 is going to round to what? It's going to go to 4. All right. So that's going to go to 4 there. So now this is going to be C3H4. That's the empirical formula. So if you look that up, you'll find out that that is the hydrocarbon propylene, which is PROPADINE. All right. So anyway, you guys have a snarly day. You be awesome, and we'll see you back here at Moose and Chemistry.